So the light is, well, the photons are zero rest mass, is always having some kinetic energy. Okay, so this concept was developed by Albert Einstein, is well, I think. So based on different type of concept theories are developed, is one of the famous scientists well, and energy in photon can be explained by using also by taking the different type of concept. Okay, so it's mainly light is mainly dependent on frequency. So this Maxwell's constant based on frequency is developed one equation that is called radiation energy. Okay, E is equal to H into V. Well, E is equal to photon energy. E is equal to is a mathematically is given an expression. E is equal to H into V, frequency V. So E is called photon energy, and that is called radiation energy. H is called Planck's constant, and then frequency. E is called frequency. So this is given the explanation about light like this. E is called energy gained by the photon. Okay, and A is equal to H into V. Is depending on a frequency. If the frequency is high, the energy is more. Okay, it's depending on frequency only. So it's given an expression like that. E is equal to H into V. So ionization. So ionization. So under ionization, so it is having atom as having electrons and protons and neutrons, electrically neutrons, atoms like this. If we are giving the energy to this, it will become ionized like this. Okay, if you are giving the energy, external energy, you are passing to the this atom, then electron will become ionized and then free. It will become free. So this is called photoionization. So once energy is passing to this atom, and the electron will be ionized and it will become free like that. So once electron is free, it's called current. Okay, flow of free electrons is called current. If the electrons are free, then current is established. So this is the source of light. Here source is light. Not only the light, anyway, we are giving some supply externally by using high voltage systems. That is one energy. Here light is energy. We are taking energy. So if energy is positive on the metal surface, and then it will be the electrons will be ionized and it will become free. So for example, the metal surface, this is a metal surface. In the metal surface, the light is passing on like that, and the electrons are released. The light energy is falling on the metal surface, then the electrons are released. This is called photoionization, ejection of electrons by photoionization. Okay, so this is the concept under photoionization. Okay, it's clear all of you, I think. Then coming to our subject. Okay, so these are the last starting onwards. We have completed a basic introduction about gases. So there are different type of gases are there. Gas type of materials are there. Okay, I mean nitrogen, carbon dioxide, and I know when. So different. These are the different type of gas type. Under gas type, these are the generally you can consider gas type materials, dielectric materials. And this concept can be explained by using different type of theories, Townsend's theory and streamer theory. These are the two types of discharges, discharge process, self-sustaining discharge and non-sustaining discharge. These are two discharging process, self-sustaining discharging process and non-sustaining discharging process. Okay, so here, so in this between, the one plate is acting as a one electrode and is an electrode. So in this way, air acting as a dielectric material. If the air will be ionized, if we are applying high voltage during transient condition, the high voltage appear between these two, and then it will become ionized and it will acting as a conductor, and electrons are released and it will be acting as conductive path. Even the switch is open, but is in under conduct mode only. Okay, that is the problem we are facing. The dielectric strength of the air is less. It's up to certain limit only. That's why we are concentrating on a different type of dielectric materials. So instead of using air, we are using here one is called SF6. So then dielectric strength of the air is in between these two, dielectric strength of the SF6i that can withstand the system effectively. Okay, we are thinking here the switch is open, but here current is passing into the conductor. But if you are thinking, if you are not look at here, if for example, to open the system, to isolate the LT system from fault system, at that condition, we have to open the switch. Even the switch is open, but is in under contact mode, at that condition, we have to, if unfortunately we are touching anyone on the line, So that may be dangerous to the human beings. That's why, so dielectric strength is must. Okay, once the switch is open, compulsory under open, it acting as an open like switch. Then only it is safe. Even though switch is open condition, it will be acting as under short circuit condition. Then even though switch is open condition also, the current is passing like this into the system. So this is very dangerous. Okay, so that's why. So we are concentrating on the dielectric type materials. Okay, so this the concept of the gas, okay, dielectric material can be analyzed by using different type of concept. Okay, so ionization by collision, photoionization, secondary ionization, electron attachment process. These are the four concepts under ionization. So these are under only uniform distribution. Uniform distribution, non-uniform distribution. So it's Townsend'S theory is not valid for non-uniform distribution. This is the one of the main disadvantage of the Townsend'S theory. Is not valid for uh, non-uniform distribution of the air. Okay, insulating material, gas or gas insulating material. If you non-uniform distribution, the Townsend'S theory can be explained. So the ionization by collision, well, I think so the same like the switch. Okay. So here, so it acting as a one plate here, same cathode is cathode. Okay, it is the anode, same, it is the anode. Same concept. Okay. So high voltage appear means from generating stations, we are connecting some system. By using substations, we are connecting the transmission line. Same in between, what will happen, we have discussed already. Okay, so ionization by collision. So when electrons, when you are applying the high voltage between these two, the electrons are released and the electrons are collide with the atom, and then the atom will become positive ion, and then that ion releases one electron. I mean, it lost this one electron means nothing but it will become ion. Okay. So at that condition, this current free electrons are available in between these two plates more than current I. Current is increases in between these two. Because of that, there is a short circuit appear between these two. Okay, so that's why we are studying ionization by collision and ionization by photoionization. Okay, ionization by collision, photoionization, secondary ionization, electromagnetism. These are the different type of concepts can be analyzed by using. This is a practical way of explanation. Okay, based on practical only, so they are developed with the theoretical concepts. By doing the practical experiments, they are developed. That's called Townsend'S scientist. They developed this type of concepts. Okay, this is under ionization process. Ionization by collision, electron collide with atom, then it will become positive ion. It releases the two electrons. Okay, and this, in between these two. I mean, the positive ions are also increasing. In between these two, positive ions are increasing and electrons also increasing. So positive ions are increasing nothing but that's called secondary ionization. So that is under secondary ionization. It's clear. If the electrons are more, it means current is high. So because that air will be ionizing, it will be acting as a conductor. So that is the probability of gases. Gases under gases if you are using as a because of the air has a dielectric strength is up to 31 kilovolts per centimeter. The air cannot withstand that much of voltage. So at that condition, if a high voltage appear in between these two, so very difficult to withstand that much of voltage levels. That's why we are concentrating on ionization by collision. So this is called ionization by collision. Ionization by collision, and next photoionization. Okay, this is called the Albert Einstein is explained E is equal to hv. No? And radiation energy is equal to hv. So this energy is falling on the metal surface. Metal surface is having atoms, and then electrons. Once ion electron is ionized, and it will be released the electrons like this. It's clear. So like that. This is the condition must be satisfied. Then only its electrons are released. Otherwise, they to emit the electrons is not possible. Okay, lambda is less than or equal to c into h divided by v. I c is called velocity of current speed. I mean, light speed, velocity of light. H is called Planck's constant. V is called ionization potential. If you are substituting light and Planck's constant, then it will become 1.27 to the power of -6 by V. So wavelength and ionization potentials are, these two are inversely proportional. If you are applying high voltage means the wavelength is required is less. If you are applying less amount of energy externally, we are giving less amount of energy, then lambda wavelength is decreasing like that. This is the condition must be satisfied. So next, secondary ionization coefficient. So on that secondary ionization coefficient, we are already discussed some concept. Electron emission due to positive ion impact, electron emission due to photons, and electron emission due to metastable neutral atoms. Electron emission due to positive ion impact is nothing but in between two plates. If high voltage up here, at that condition, the electron will become is collide with the atom. Okay, the electron is collide with atom and then releases the one electron, and one more electron, two electrons are released, and it will become positive. Again, this positive ion is collide with the negative plates. There is a collision occur between positive ion and a negative plate. Because of that, the electron is, one more electron is released. That is called secondary electron. That's concept under secondary ionization coefficient. And this is called secondary ionization coefficients. Okay. So in this condition, electron emission due to photons, next electron emission due to HV is greater than or equal to 5, then work function. So energy, radiation energy E is equal to HV. E is equal to HV. HV is greater than work function, then only the electron is released. Okay, this is called under photoionization. And secondary ionization, electron emission due to metastable neutral atoms. Here, main concept is lifespan of electron. Main concept is lifespan of electron. If you are if you are taking an ordinary or particle means that is called copper or gold, or if you anything, that is the lifespan of the electron is less, 10 to the power minus 8 seconds only. Okay, if electrons are released from insulating material, okay, or a neutral atom, and from for example SF, from SF6 gas is insulating material, inert gas. So from then electron released from inert gas, okay, the lifespan of the electron is be more. So because of that, secondary ionization will be process will be there. I mean, the secondary ionization will be occur. Otherwise, if the lifespan of the ordinary electron is less, lifespan of the electron is less, the secondary ionization process will not occur. Okay, again, the secondary ionization cannot be, the process cannot be occur. It's clear. And if the lifespan of the electron more, then only the secondary ionization process coming to picture. Right? If the lifespan of the electron is lesser, the secondary ionization process cannot come into picture. So this is the concept under electron emission due to positive ion. So start here today's class. Actual today's class. This is up to here. You have completed yesterday. Up to actually yesterday class. Previous class we have completed up to this concept. So today's class, Townsend'S current growth equations. All of you write in your notes Townsend'S current growth equation. Okay, so in this Townsend'S current growth equation is explained by taking this type of simple experiment. Same as this is the practical. Okay, this is a practical circuit. Under opening condition, what will happen? Okay, how the current is increasing, how the current is decreasing when the time is increasing. Okay, so depending on time, this current between these two ionization will be different. Okay, and increasing of the current is different. Okay. Okay, so like this, assume that. So any problem if you are, is it clear or any problem?
Clear.
Okay, so okay. Some of you are, I think, others you are on. Okay. So all of you draw this again, so, diagrams and the circuit diagram, and also this also. So during the initial condition, assume that n0 electrons are emitted from cathode. Okay, during the initial condition is when we are giving the power supply, when you are applying the high voltage to these two plates. Initial condition means once during the transient condition. Okay, during the transient condition, the electrons are released. That electrons are called n0. I mean the electrons at cathode plate. So the number of electrons are how many number of electrons are released. That number of electrons are we are denoted as n0. Okay, During the initial condition, the n0 electrons are emitted from the cathode. That can consider as at x is equal to 0. Okay, when they are considered at cathode place, specific distance, that is called specific place only. That is called cathode plate. Okay, at cathode plates, the n0 electrons are released. X is equal to 0 distance. Okay, this is called D is called total distance between two plates. So like this, in between these two, this total distance D from the cathode. So when electron collide with the neutral particle, the positive ion and the electron form, collision. Because of collision, the electrons are, when the electron is released, and this collide with atom, and it will become ion. Okay, positive ion and electron, one more electron released, and this called ionization process. Okay, it's composed into. So like that, so what will happen during the transient condition means? So during the transient condition, once when we are switch on the high voltage to the in between this, once during the transient condition we are opening the switch, during the transient condition, what will happen? The electrons are released exponentially. Okay, increasing, slowly increasing. Okay, slowly increasing. The electrons are increasing slowly. So like this. So it will be acting as a like this, slowly increasing in this manner. Okay, up to a certain time, the electrons are released from negative plate, slowly increasing, and then after that, some distance, after some time, the electrons in between these two is constant. The slow is constant. Even though voltage increasing between these two, the emission of the electrons is constant. So like that, the graph will be like this. Okay. So after certain time, what will happen? This air completely, this whatever the air is present in between this, whatever the gas is present in between these two, it's complete ionized. As it is under open condition, that's why the air will be replacing of air is possible. But in closed manner, the replacing of air is not possible. So once air is completely ionized, so what happened completely is suddenly is increasing like this. Am I right? Suddenly is increasing. So voltage suddenly increasing. This called current. This called current, and this called voltage. Even though voltage is increasing, the current is increasing. So in this manner, it's clear. So all of you completed this diagram, and then we'll come into graph. During the transient condition, okay, from year to year, so this current is slowly increasing. So once the switch is open, this current is slowly increasing. After certain time, this current in between these two is constant because of this time, because of ionization. Okay, so ionization of the gas. That's why the current in between these two plates is constant. In between these two plates, up to certain time, in between these two plates, current is constant. During the transient condition, starting condition, current is increasing like this, and up to certain time, okay, so then current is constant because of process under ionization process, and then after some time, the electrons are used, electrons are released, and the current will be suddenly increasing, even though voltage is constant. It's clear. Up to here, this voltage is constant. It's clear. So up to during this transient condition means when we are applying the high voltage to the system, between these two plates. Okay, when you are applying the high voltage to the dielectric material, that is called air, gas, and nitrogen, or whatever it may be. So during the transient or up to this some time, initial time, the current is slowly increasing. Okay, so in this period, the voltage is also increasing between these two. Okay, once voltage slowly is increasing, okay, the current is slowly increasing. Up to certain time, the current is constant. Okay, the current is after certain time, because of high electron between these two plates, this high current will be high current is appear because of availability of electron. 3 electrons are more. That's why even though voltage is increasing, up to behind this point, voltage is increasing. Okay, this current is constant like this is increasing. Even though voltage is constant here, up to here voltage is constant. Up to certain year to year, voltage we are increasing. Okay, voltage increased. So even though voltage is increasing or decreasing, irrespective of the voltage, the current is goes on increasing like this. Okay, so that is called ionization. Townsend'S is explained how the current is increasing between two place, that is called how the current is increasing across the dielectric material. That may be SF6 or so whatever it may be. So the variation of the current as a function of voltage is studied by Townsend'S. Okay, variation of current, this is called variation of current, and the variation of voltage, and is explained by Townsend'S. Up to certain time, the voltage is increasing, and the current is also increasing during the transient. During the initial condition, the current is increasing like this, and sometimes it is constant. After that, even though voltage is increasing or decreasing in respect to the voltage, the current is sharply increasing because of that. And suddenly, spark is appear in between this. At this position, spark is appear. So year to year, spark is not appear. Okay, so because of free electrons are up to here, there is no free availability of free electrons are less up to this position. But here, the free electrons are up to here. The free electrons are available in two places, that is called across the dielectric material. The free electrons are more because of that high electrons. There is because of high current. Okay, that because of that high current, the spark is appearing. The dielectric material lost its property. At that condition, is current is like a impulse. Okay, so like an impulse suddenly is increasing. Okay, suddenly increasing because of that spark is appearing between these two. Spark is appearing between these two. Okay, that is the process of is explained Townsend's concept like this. The exponential increase in current due to ionization gas by electron collision. Okay, you know well ionization by collision. Next, so try to observe here the variation of the current as a function of voltage was studied by Townsend's. Okay, he found that the current first is increasing proportionality, the voltage is increased and then remain constant. Up to certain time, the voltage increasing, current is increasing up to certain voltage. Then if you are increasing the voltage levels or decreasing the voltage levels, the current is constant. Is I current is because of that spark is appear. As the voltage increases, you know well, electric field E is equal to V by D. You know formula, I think E is equal to V by D. So voltage per is called V is called voltage, applied voltage, and D is called distance. Okay, so E is equal to V by D increases, and then the electric field between two plates across the dielectric material is increases as the electrons are accelerated more and more between collisions. This acquire higher kinetic energy and therefore knock out more and more electrons. So like that is explained ionization by collision between the two plates. Okay, first is taken one proportional constant. So number of electrons are increasing means current is also increasing. That means electron is proportional to the current. Current is proportional to electrons. Am I right? If current number of free electrons are more means current is also high. The number of free electrons are more means current is high. So that means current is proportional to the number of free electrons. So if you want to remove the proportional, okay. So what you have to do, we have to introduce one constant that is called alpha. Is introduced one constant alpha. You know well, voltage Ohm's law, just like Ohm's law, V is equal to I into R. V is proportional to I. So Ohm's is a scientist. Is introduced one element that is called R. Proportional constant is called R. V is equal to I into R. Same as here also is given on one proportional constant that is called coefficient. First ionization coefficient that is called alpha. To explain the exponential rise in current, Townsend introduced a coefficient of alpha that is called Townsend's first ionization coefficient. Okay, alpha is the number of electrons produced by an electron per unit length path in the direction of field. Are we clear? So alpha is called Townsend's first ionization coefficient. Okay, so at transient at starting condition, the electrons are released like this. Okay. During this transient condition, the electrons are released from cathode place, that is called N naught has the electrons. During the at this cathode place, the electrons are released N naught. And once when we are across the anode, the number of electrons are nothing but ND. Total number of electrons are ND. So like that is explained Townsend's first ionization coefficients. Okay, coming to here, some small derivation is there. Is given one explanation about by using mathematical derivation is explained. Assume that N naught is the electrons are emitted from cathode. When one electron collides with neutral particle, a positive ion and electron are formed. This is called ionization collision. You know well. I've already explained so many times. Okay, ionization by collision. At any distance x, the cathode let the number of electrons be next. Okay, if you are increasing, if you are, for example, if you want to observe the number of electrons in between up to certain distance, so that is called dx. So total distance x, that is equal to d total d. If you are assuming, if you are considering up to certain distance only, okay, so that is called an x dx. At any distance x from the cathode, let the number of electrons be an x. The rate of flow of electrons is called current, is written by like this. So change in number of electrons, when increasing change in electrons, that's why change in current. So number of electrons are changing, dnx is equal to, okay, nx into alpha into dx is proportional to distance. Okay, so dx, change in distance, dnx is equal to nx into is called proportional constant alpha is introduced. So like this, proportional constant. dnx is proportional to nx into dx actually. dnx is equal proportional to nx into dx. So you introduced one proportional constant alpha, that is called first ionization coefficient. Then derivation of integration of dnx by nx. Okay, it's coming to denominator, and so we are getting like this. ln of nx is equal to, if you are applying anti-log, so log, so you will get like this ln x. You know well, I think mathematical like this. Alpha into x into the constant. Okay, so initial conditions, the number of electrons are n naught during the x is equal to 0. At x is equal to 0, at x is equal to 0, how many electrons are there here? N naught. So that A is nothing but N naught. It's clear. After completing the session, I mean, within 4 minutes, this complete session, all of you rejoin again. Okay, all of you rejoin again. I will explain Townsend'S current growth equation complete today. Okay, by pressing the same link, all of you rejoin again. So this is the, so A is called initial conditions. X is equal to 0. You know well, distance x is equal to 0. No? During the transient condition at cathode, x is equal to 0. X is equal to 0, and initial electrons are at cathode plate is called n naught. So that is called Na x is equal, at x is equal to 0. All of you write this. At x is equal to 0, 0 distance, that means at the cathode plate. X is equal to 0 and x is equal to n naught. Number of electrons are released from cathode plate is called n naught. During the initial condition, the number of electrons are called n naught. ln of n naught is equal to, x is equal to 0, 0 plus a. So then a is equal to n naught. This is initial. Substitute here in between the across the, I mean, before, substitute here. Okay. So like this, we will get like this. ln nx is equal to alpha into x in plus ln l naught. Then ln x, so it's coming to the left side when we minus ln of n naught is equal to alpha x and x by n naught is equal to power alpha x and x is equal to n naught into e power. So this is the equations, so very very important. Number of electrons reaching to the anode x is equal to d. If distance x, so we are finding the number of, how many number of electrons are reaching at x and x. So that's why nx is. If you are finding the number of electrons, how many electrons are reached to the at pass to plate, that is called anode at d distance. Substitute x is equal to d here, and d is equal to n naught into power alpha d. Like that we are getting. So all of you observe, I think, you know well, the current is increasing, number of electrons are increasing in a linear exponential manner. Exponential manner. So this called number of electrons are nothing but current. If more number of electrons are more, nothing but current is increasing. Current is proportional to the number of electrons. The number of electrons are more means current is also high. It's clear. So nd is equal to n naught into e power alpha d. X is equal to d. If you are substituting, nd is equal to n naught into e power. Then the average current in the gap equal to the number of electrons traveling per second. It's clear. id is equal to n naught into e power alpha d. So nd is nothing but is proportional to the total number of electrons is proportional to the nd is proportional to the id. Okay, and initial current because of initial number of electrons n naught is proportional to I naught. Okay, so n naught is proportional to I naught. id is equal to I naught into e power alpha. Average current in the gap is equal to the number of electrons traveled per second. So that is equal to ID is equal to I naught into E power alpha. I naught is called initial current cathode. You know well, initial number of electrons are called L naught. I naught is called initial current at cathode. E power alpha D is called electron average. Okay, so it represents the number of electrons produced when the electron traveling from cathode to anode. The equation one is called Townsend'S current growth equation due to primary ionization coefficients. Okay, primary ionization coefficients ID is equal to I naught into E power alpha. So like that is explained primary ionization coefficients. So because of this, so exponentially is increasing. Okay, is proportional to the E power exponential. That's why the current is increasing slowly. So that is represented in the. So like this, ID is equal to I naught into E power alpha. So like that. So all of you rejoin again. Okay. So complete. I think it is ended within 1 or 2 minutes. 1 minute. I think is all of you clear? I think the ionization by Townsend's ionization by Coulomb.